Today we're going to be taking a look at how we can use the ideas of timing execution of code so we can see how effective recursion is, using it to solve different problems. We're going to look at the regular recursive method for the Fibonacci sequence, as well as a much more better version by using dynamic programming, specifically memoization, so we can have a much faster execution, but still use recursion to actually try calculate the value for the Fibonacci sequence. So we have this little timing method right here that I call my start method. And as you can see right here, I'm making an array of ints, 40 size. I'm deciding discovered sub 0 to be 1 and discovered 1 to be 1 as well. And then I have the use of a system.nanotime so we can get the nanoseconds we're working with when we're calculating that. And I grab the time from that, and then I call calculate Fibonacci 39. And I also then call time is minus equal to system.nanotime. I don't actually need to use or store the Fibonacci sequence. We simply need to do the calculation of it to see how long it takes to actually get that information. And so we're going to figure out how much time it took to do that. And so I have math.abs passing it time right here in line 41. And the reason I'm using math.abs is nanotime can potentially give back a negative value. And so to make sure we're doing the proper amount of display for information, we have that right there. Then we're doing long memo time as system.nanotime and memo fib passing to discovered.length minus 1 to get that same amount of 39 for that spot. And then do memo time minus equals system.nanotime. And then do system.println. It took math.abs memo time nanoseconds to calculate that. And then we're going to do a little bit of formatting with this so we can make it so it looks a lot nicer so we can actually see that information. And so in this case, what I'm using is I'm using the NumberFormat class. It's in java.text.numberFormat. And so I do NumberFormat %format equals NumberFormat.get %instance. So I'm getting an instance of the NumberFormat using that factory method right there. And then do %format.set minimum fraction digits 3 so I can get 3 digits of fractional value on that. And then double result is equal to, and then doing double division, so double in parens, memo time, and having that all parensed out, and then passing that divided by time, and system.println percentage colon and %format.format passing it result, and then NumberFormat double format equals NumberFormat.get number instance, and doing a double format this time with just a fraction digits of 4. So a little bit instead of using a fraction, we have just a number format. So instead of getting the e to the whatever power or 10 to the whatever power version, we see that we're going to have it display with that information. And so we can get that information right here and have that display. So let's go ahead and run this and take a look at that. Before we do that, again, just a quick review for the Fibonacci sequence. We have our standard recursive definition right here, calculate Fibonacci, and we pass it data equals 0 or data is equal to 1. And then we have our memo fib version. If discovered subdata is not equal to 0, I return that value. Otherwise, I assign the value into the array and return that value from the array. So I'm making sure I get that value right in there and ready to go. So that's what we're doing to make sure that happens using memoization. And we run that code, and it took, in this case, 590 million nanoseconds to calculate the 40th Fibonacci sequence versus using the memoization version. It only took 12,000 nanoseconds, which is only 0.002%. 0.0000, oh my gosh, wow, that's way faster. And so if we don't use that number format tool like we did right here, we're gonna get 2.06275 times 10 to the negative 5th, which if you're not working with, or used to working with the idea of scientific notation, might be a little confusing. And so by using the NumberFormat tool, we can make that look so it's a lot easier for a human to understand and look at. And all we have to do is import java.text.numberFormat, and we can do some cool formatting with that. It also makes it so I don't have to worry about doing the joy of system.printf stuff and making it look all messy. And so it's a nice object-oriented way to do formatting of text and have it look a lot nicer. And so that's what we can do to get a quick little idea of how we can time results. Again, when we're timing data, we don't need to actually store that information. We simply do the calculation, then subtract out the current time in nanoseconds so we can get that value back, and we're ready to go. That's just a quick way we can do a quick time of Fibonacci sequence using memoization or standard recursion to see how long and how effective it takes to calculate that information. Hope that's a great term for you. Have a great day. We'll see you next time. Bye-bye.